So this is the third way of connecting a transistor. So what do we have here? Like at B, at the base, we're using a potential divider. So that would be the case when you have a sensor, for example, here, instead of R2, you could have a sensor. So that's typical type of connection you might have. So the first thing we need to do is to calculate the point here, the voltage, the potential at this point, which is going to be VB. So the voltage at this point is the, remember here you have 0 volt, so that's the voltage across R2. So we are looking for VR2. So VB is equal to VR2. And if we use the potential divider formula, which is R2 over R1 plus R2, multiplied by VCC. Voltage at this point is the same as the voltage here. So VB is going to be 10,000 over 32,000 times 12. So that gives you 3.75 volts. Now, that's VB. Across VB, remember it's a diode, so you always have 0.7 volts. So it means that VE is going to be 3.05 volts. Here again I have 0 volts, so if I have 3.05 at this point, it means across VRE I'll have 3.05. So IE will be VRE across over RE, which is 305 over 680. Give me 4.48 milliamps. Or 8, excuse me, the 8 more. 4.48 milliamps. That's IE, so that's the current going down here. Now with alpha DC is equal to 1, okay? So IC is equal to IE, it means IC is 4.48 milliamps. Now that I know the current here, I can calculate the voltage across RC. VRC is RC IC, so that's going to be 1200 times 4.48 10 minus 3. Okay, that's 5.38 volts. So if I lose, I start at 12 here. If I lose 5.38 in the resistor, then at VC, the potential at C is going to be 12 VCC minus 5.38. Give me 6.62 volts. Okay, so now I can calculate VBC or VCB, whichever you want to call it. 6.62 minus 3.05. 3.05. So 3.57 volts. VB we know VC, we know VB, we know VE. VC is going to be 6.62 minus, oh sorry, I made a mistake, that's actually VC 3.05 with 3.57. Here BC is at 7.5. My mistake. This one, so that's 3.57, and this one would be 6.62 minus 3.75, 2.87, excuse me. So 3.57, 2.87. And the final thing we need to calculate is IB. IB will be IC divided by beta DC. So IB will be 4.48 10 minus 3 by 100. So that's 4.48 10 minus 5 amps.